All right, lesson number 8, the final lesson of the unit here. We're going to solve absolute value inequalities, and your learning target is I can solve inequalities in one variable involving absolute value expressions. Let's go. So the key concept here, in order to solve and graph inequalities involving the absolute value, the very first thing you want to do every time is isolate the absolute value symbol. That's what we have to do the very first second every single time, okay? After we do that, the second thing you need to do is to drop the absolute value signs and split the inequality into two different inequalities, okay? This is really important, this part, so listen up to this part especially, okay? One of those ones that you split, you're going to keep the original outcome and inequality sign. Okay, it's going to stay the exact same. For the other one that you split, you're going to make it an opposite outcome, meaning that if it was positive, it's going to be negative, and if it was negative, it's going to be positive. And then you're also going to flip the sign, okay? And then, after you do that, solve each inequality, and finally, the third step is to graph the set of solutions that will make both inequalities true. Okay, here we go. Example 1 says to solve the inequality x plus 4, the absolute value of x plus 4 plus 2 is less than or equal to 4. So let's go ahead and I'm going to go ahead and rewrite this first. That way we can kind of work through it better. Okay, sorry for the zoom in. Okay, so the very first thing that we need to do is we need to isolate the absolute value. We see the absolute value is being added by 2, so we need to subtract 2 from both sides first. From both sides of the inequality, and we'll be left with the absolute value of x plus 4 is less than or equal to 2. Okay, at this point we need to start the second step, which is to split the inequality into two different inequalities. Okay, so we're going to split it into two, and the first one is going to stay the exact same. You're going to drop the absolute values, and you're going to do x plus 4 is less than or equal to 2. And the second one, you're going to still drop the absolute values. However, you need to flip the sign. So instead of less than, now it's greater than. And set it to the opposite outcome, which this is a positive 2. Now it's going to be a negative 2. Okay? And then we go ahead and solve each one. So let's go ahead and do this one first. We're going to subtract 4 from both sides. We get x is less than or equal to negative 2. Again, subtract 4 from both sides in order to get rid of this here. We are left with x is greater than or equal to negative 6. Okay? All right, after you do all that, we are going to have to graph it. So, bam, a graph is born. And then we just graph both of these inequalities like a compound inequality, right? So x is less than or equal to negative 2, so let's put a dot at negative 2. Okay, and then we have x is greater than or equal to negative 6, so let's put a dot at negative 6. And then let's graph to make these true, right? If x is less than negative 2, that means this direction, we're less than negative 2. But x is also greater than negative 6. That means we are filling in the and section, the intersection between both of them, to make both of those true statements, okay? It's the intersection of them. Let's do example 2. Same type of thing here for example 2. Let's go ahead and first rewrite 3 plus x plus 2 is greater than 5, the absolute value of x plus 2, of course. And let's first isolate the absolute value. So we first need to get rid of this positive 3. So we're going to subtract 3 from both sides, and then we'll be left with absolute value of x plus 2 is greater than 5 minus 3 is 2. Okay, and now we split the inequality. We've isolated the absolute value. Now we split the inequality into two different inequalities. We've got x plus 2. We drop the absolute value signs as greater than 2. Nothing changes for that one. And then the other one, when we split it, we have to flip the sign, make it less than now, and make the outcome opposite, which is now going to be a negative 2. Okay, now it's still the same thing. We're going to solve each one. So we got to subtract 2 from both sides. We end up getting x is greater than 0. Subtract 2 from both sides. We end up seeing that x is also less than negative 4. Okay. Then finally, we made a compound inequality, so we need to graph this. So we got to graph it now, and we put x is greater than 0. So we're going to make a mark at 0, and x is less than -4. And if we graph those individually, we'll see that x being greater than 0 has to be this direction, and x being less than -4 has to go in this direction. So it's kind of an either or. It's either x is greater than 0 or x is less than -4. All right, let's move on. All right, example 3 asks us to solve the inequality again, but I want to point out something real quick. This one won't take that long. We see that x plus 4, it's the absolute value, and we know absolute value means everything has to be positive, right? Everything has to be positive, and so that saying that it's greater than -8 means that all real numbers will work for this. All real numbers are going to work for that. And so if you were to graph this, let's just say we've got -1, 0, and 1. Something like that. It would be everything. It would be absolutely everything shaded. Because all real numbers will make that inequality true. All right, example 4 says to solve the inequality. Again, we need to get the absolute value by itself. So let's go ahead and rewrite this. We've got x minus 2, the absolute value of x minus 2, plus 9 is less than 7. Okay, we're going to subtract 9 from both sides. We end up getting the absolute value of x plus 2 is less than -2. But what we know again about the absolute value is that absolute value has to be positive. And it could never be less than a negative number. It could never be a negative number. And so what that means is that this solution is no solution. Your graph in this case you wouldn't do anything for, because there is no values that would make those equal.